we started off by talking about project management. And specifically, the way that we did that is we outlined a case study for a customer called Acme Audio. And Acme Audio was using SOLIDWORKS Manage to address a lot of their project management needs. Today, we're going to take one of those tasks that we got assigned outside of our Manage tool, and we're going to go ahead and take that to completion. And that task is going to be addressing our electrical design tool. Now, if you're saying to yourself right now, hey, I'm not an electrical engineer, I don't do this kind of work, just stick with me because I'm not either. But what we'll be walking through is not just the electrical design, but how this affects all of our downstream products and our downstream team members, along with how we can share this electrical design content. The way that we're going to do that is we're going to first walk through the goals of Acme Audio. So the first goal from an electrical design standpoint is they have to lay out the actual PC board design. From there, they have to be able to produce an output that they can share with their PCB manufacturing vendor. Along with that, the sales team has a requirement of being able to have a line diagram to show how the overall audio system is going to be functioning or maybe being installed. Once we get awarded a project, the electrical team is in charge of detailing out a full schematic with the full front-to list and all the pin connections for the installation and for the manufacturing team. And then last but certainly not least, one of their main goals is to provide a bill of material to the ERP and into the manufacturing team so that way they know actually what to purchase. Now, how is Acme Audio literally doing this? Well, they break this down into two kinds of design. They have what they call their PCB design, which is their actual discrete circuit board design, and then they're breaking it down into what they call the schematic and harness design, which is your general 2D schematic and harness layout that has your eBOM for manufacturing. Now, let's break out the whiteboard and let's talk about what Acme Audio is currently doing. What does their process look like before they found their most optimal solution? Well, the first thing is they were using a standalone tool to design their boards. And that tool in this case was actually Visio. They were literally just drawing the board in 2D and laying it out, laying the different layers out in just a normal 2D application. They were also using AutoCAD, which is just 2D line schematics that had no real intelligence built into it. They would create all their bills of material manually using Microsoft Excel, which this was part of the requirement for the electrical team. And then the last thing that they were currently really doing a lot of was doing a manual import into 3D SOLIDWORKS. And this was so that way they could actually do simulations on both the boards and also manually routing wires to make sure that they actually had real wire links. So this is what Acme Audio is currently doing, and you might find yourself in a lot of the same things that they are. So what are the challenges of their current methodology? Well, the first challenge is that they really didn't have a way to integrate with the 3D design team. So what that means is that every time they needed to put something in the 3D space, it was always a manual import and a manual export, and the information didn't flow back and forth seamlessly. The other challenge was that they really didn't have a way to simulate the real-world environment. And so in this case, what we're referring to is to actually do an analysis on the board, right, with a SOLIDWORKS simulation or SOLIDWORKS flow. And also, they couldn't simulate the actual wire links because they didn't have a seamless integration between their schematic tool and SOLIDWORKS 3D. The other big challenge was that their bills of materials weren't always accurate. And the reason they weren't accurate wasn't because the electrical engineer wasn't doing his job correctly. It's because they did a lot of iterating. And since this was a manual process, that was a big challenge for them to always make sure that they went back and updated the bill of material after a change in the electrical system. And then the last thing is they really had no way to integrate with their downstream teams. And what I mean by that is to be able to take either the schematic or the board layout or the electrical bill of material and manage it and share it with the project team. So what that meant is that anybody on the project team or the manufacturing or the mechanical design team, if they needed something, they always had to physically go find the electrical engineer or email them or use a disjoint tool to get the information from the electrical team. So how did Acme Audio solve all of these challenges? They transitioned into two of the MLC tools. One of those tools was SOLIDWORKS PCB, which is what they are now using to do their circuit board design, and leverage SOLIDWORKS electrical schematic and 3D routing, so that way they could get a true harness layout and a true schematic of the overall system. Now, what we'll be going over for the next 15 or 20 minutes is I'm going to pass this off to one of the smartest people I know, and that's Mr. Jeremy Browning. He is a part of our electrical engineering team, and what he's going to do is he's going to take it from here and show you how Acme Audio is using these tools in real life. Jeremy, I'm going to go ahead and make you the presenter, and you can take it away.
Thanks, Roland, for the introduction. Being the resident electrical nerd here at Acme Audio, I know how challenging it can be to integrate the two engineering departments. Many companies are using disjointed tools and lack communication from one team to the next. Today, I'm going to show you a few ways that you can bring the information and designs that your electrical team are creating into the mechanical space. Starting here in SOLIDWORKS is our Acme boat. It looks like the mechanical team is pretty close to completion of the design, but we need to confirm that our PCB fits into the space allocated. We also need to confirm that we have room to run our wires to hook up our stereo system so that we're the loudest boat in the cove. In the system, we have a left and a right speaker, a subwoofer, and a receiver that plays music. We also have an amp that powers our speakers, and finally a battery that powers everything. There are speaker wires, RCA cables, and power cables that need to be ran in the boat and then custom ordered so that we have the right length when it comes time to manufacturing. Let's start digging into the PCB design first. Our main challenge here is not necessarily going to be the board design, but rather fitting that design in the mechanical package. In traditional siloed tools, engineers must deal with board shape exports in the form of DWGs and DXFs that need to be roughly modeled by the mechanical engineer who may or may not know the reasoning behind the design and layout. With our Acme Boat Company, we've decided that we're going to use SOLIDWORKS PCB as our board design tool, which gives us integrated designs without any need for exporting from one system to another. Here we have the amp enclosure, and we need to confirm that the board can fit into it. We already have a rough board shape, but this will obviously not work well. I can edit the board shape in context of this top-level assembly and use a sketch shape that's already been approved to fit by our mechanical engineer. Now that the board shape has been changed, we need to notify our electrical engineers so that they can confirm that there are no major issues. This is a very simple task using the PCB connector. All we have to do is give this a change description and hit push. This will give us a change notification to our electrical engineer in the project he's working on. Let's switch over to SOLIDWORKS PCB. We're now playing the role of electrical engineer. SOLIDWORKS PCB is a full-fledged PCB design tool. The full name is actually SOLIDWORKS PCB powered by Altium Designer, but we can just call it SOLIDWORKS PCB. If you already own Altium Designer, then you can continue to use it and purchase the SOLIDWORKS PCB connector so that your team can communicate like you see here at Acme Audio. SOLIDWORKS PCB is both a schematic capture and board layout tool, including libraries, automatic net routing, and real-time rule checking. Here in the PCB connector pane, there's a note indicating that there has been a change made by the mechanical team. We can preview this change to be sure that those crazy mechanical engineers did not throw a grenade at us before we finally accept. Now that we've accepted the board outline, we can push mounting holes, silk screen information, or even solid copper to be used for thermal studies into SOLIDWORKS. For Acme Audio, we're going to call this design complete and generate our output files for manufacturing. Let's switch gears a bit and take a look at our cable and wire routing needs. SOLIDWORKS Electrical is a great tool to generate schematics and create routes to get your fit, form, and function and length correct. SOLIDWORKS Electrical is a standalone application for any schematic need, including hydraulic and pneumatic schematics. Why it was not called SOLIDWORKS Schematic, I'll never know, but maybe one day we can get it changed. We here at Acme Audio have generated a few layouts to show both the power and audio signal distribution. On this last page, we've created the actual schematic that drives the 3D routing. SOLIDWORKS Electrical is an intelligent schematic tool that keeps track of each component from a project level and understands that you can have multiple symbols representing the same physical device. I think my favorite benefit of using SOLIDWORKS Electrical is how it allows our team to standardize the look of our schematics and parts used for our projects. Now there's no more guesswork when it comes to what parts we need to use and order. The information is driven by a parts library that you can add to easily through the Electrical Content Portal website hosted by SOLIDWORKS' parent company, Dassault Systems, or like we like to say here in Texas, Dassault Systems. Reporting in SOLIDWORKS Electrical is a breeze since we can set up standard reports geared for different audiences. I can have a BOM for order entry broken down by vendor, as well as inventory pick lists sorted by location. Reports are generated basically instantaneously with zero effort once configured. I never have to worry about missing or incorrect data again due to the built-in error checking that we call design rule checks. Now we need to create the physical routes inside of SOLIDWORKS. The routes are based off of a 3D sketch called an EW path. This is a guide that the routes will loosely follow. You can think of this as a route skeleton. Routing is almost a one-button command using the route wires button. To save time, I'm going to use a 3D sketch route rather than a solid route. The only difference here is there's not going to be any solid created. This also has the benefit of not creating a very large number of graphics triangles that would ultimately slow down your top level design. The route sketch colors are based off the wire settings from our schematic standards. Even with the 3D sketch routing, we can take advantage of the lengths generated. These lengths can now be pulled in a report so that we are 100% confident that we have enough wire and cable. Once we have the electrical project complete, we can now check this into our PDM vault so that the rest of the company knows that our section of this larger project is complete. Roland, how does the integration between ECAD and MCAD look to you?
Jeremy, the integration looks really solid. Let's go ahead and finish up our project and continue where we left off from last week. What we want to do is we want to go ahead and modify our project bill of material and our project deliverables using all the information that our electrical team has provided for us. In this case, we're going to go ahead and open up our existing project, and we want to tie two things to this project. The first thing that we're going to look at is we're going to look at our process plan. If you remember from last week, this process plan gives a timeline and gives the ability to assign tasks and assign project deliverables for each task. In this example, we're going to go to our project deliverables for the electrical design stage, and we're going to go ahead and add the 3 deliverables that we need that are essentially the output for our electrical team. Since SOLIDWORKS Electrical and PCB are so tightly integrated with PDM and Manage, it's very simple to navigate and find this information. In this example, what we'll do is we'll go ahead and go to Jeremy's project called Acme Audio Boat. We'll go into the appropriate location, and we'll get the 3 project deliverables for our electrical schematics. By simply choosing Add and Closing, we now have tied together our project, which is our overall timeline, with the engineering data that our electrical team has provided. Now, on top of that, we need to modify the shipping bill of material, or in this case, what Acme Audio calls the project bill of material. Now, the project bill of material is encompassing both our electrical team and our mechanical team's outputs. In this case, we can see the bill of material that has already been tied from the SOLIDWORKS model. We want to go ahead and tie the electrical schematic that's going to give the detailer the information that they need to actually do the installation of this audio system. To do that, we'll simply go ahead and tell Manage to add. Well, again, we'll navigate to our electrical database, which is tied in the background to our system. Mr. Browning has provided our schematic in PDF form, so it's very easy to read and very easy to open. And we'll go ahead and just simply hit Add and Close. What this now does is it gives everybody in our organization access to the technical content without going into multiple systems or needing to bug our electrical engineering team to print out the schematic from the electrical tool. We can see here that not only do we have the schematic, we have our from to list, the bill of materials, our line diagram, and all the appropriate information to go ahead and install this system. So what have we done so far today? What we did today is Jeremy and I have walked through the application of SOLIDWORKS PCB and SOLIDWORKS Electrical. We also illustrated how these two tools can be integrated with the rest of your organization. And in this example, they are tightly integrated with our SOLIDWORKS management tools, which include SOLIDWORKS Manage and SOLIDWORKS PDM. Now, what does this do for Acme Audio? What did this accomplish for them? Now that they're using the entire suite of tools, they have a board integration that is very tightly integrated to the 3D world. In their case, it's actually bidirectional, and the huge benefit is now the mechanical and the electrical team can pass their information seamlessly back and forth without worrying about doing redundant effort or getting the wrong data. The schematic layout tool also is now providing a direct integration to our SOLIDWORKS 3D world. Again, the huge benefit for this is now we're getting more accurate bills of materials with true cut lengths for the wires, and we're able to confirm that the system is able to be in place without going through key areas or volumes in the overall assembly that might be keep out regions. And then last, but certainly not least, is we are able to share all of this data and integrate across all of our project management tools. Now, I hope you find this session very educational and very informative. But I'd like to remind you, if you haven't done so already, to go ahead and sign up for next week's session, which is where we'll be covering design automation. Now, if you're thinking design automation is just for SOLIDWORKS users or the mechanical design users, you're going to be really surprised when you show up in a couple weeks and see what we have in store. Not only are we going to be looking at automating the design, but we're going to be looking at how we can actually tie into our end user or the customer directly from our web page.